So when working with two different lists of data and we want to analyze overlap and intersections and differences, we need to learn about sets. And sets are important in maths as a concept of collections of data. And they are very useful in Python. So there are specific types of lists. And as you can see here, they are annotated by curly brackets rather than square brackets. So this is not a list, this is a set. And there's some key differences to lists. So first of all, sets can only have unique elements. So if I have a double element here, I will generate an error or it will just be filtered out. So if I have a list with two ATRs and I turn this into set, the one ATR will be lost and we'll just have the single value for each entry. This is useful if you want to look at overlap and things like that already. The other important thing is that there's no order, so it doesn't really matter which comes first, what comes next. And if I would generate the same set and change the order and then compare them and ask, are they the same? The computer would tell me, yeah, they are the same because sets do not take order into account. And sets are actually also very good if you have large amounts of data that you want to look up quickly because they're much faster to access than lists, but that's something that you don't really need to know right now. The reason why we are using sets is because they are very good at doing this logic of looking at, okay, what is only in one list, what is in the other list, what is the intersection, and what is in both lists together. These are the most useful set operation. We can turn lists into sets using simple that set keyword here. It's a method, so the set method and we just provide the list into it, it'll turn the gene list into a gene set. And we also can turn data frame columns into sets using the same technique. Right. So there's three logical operations. We can get the intersection, and there's always two ways. One is a method way, so we can say the set ATR genes dot intersection and supply the slew genes, and it will give us what these two have in common. Or there is using logical operators, so ATR genes and slew genes will give us the same result, which is here in this case only TP53 is in common. We can also get the union, so all the genes together. So this will eliminate the duplicates. So we can say union here, or we can get the difference. So here, obviously, depends on the order. So we can get only the ATR genes by saying ATR genes different slew genes. Or if you want to get this side of the data, we would say slew genes difference ATR genes. And again, here we use the minus operator or the difference method. I've put together a little notebook as usual on sets because they are quite important. They're also fun to play around with. So different type of collection to list. So it's important in your coding arsenal to be aware and familiar with this. But yeah, they're becoming very useful if you wanna compare two different data sets with each other. So what we're gonna do with these sets, we can now use that technique to generate the Venn diagrams. And there we have to introduce one more thing, which is the matplotlib Venn library. So this is a typical example of, matplotlib they haven't gotten around generating the code to generate Venn diagrams. So a kind soul has sacrificed some time to make a free and open package to supply this functionality. And this is built on top of matplotlib, but by someone else who wanted to generate Venn diagrams and out of kindness shared it with the community. And most of the code that we are using is generated in this way. So this is again emphasizing the power of open source package. So we can go and have a look at the documentation. And this will give us a clear idea of how we can import it and how we can use it. And the main thing is that you have to use sets, and you can use this venn2 function and then just supply set A and set B, and you get intersection. You get this nice plotting type, and then there's other parameters, and there's different ways of making things more elaborate and adding more information. So you can look through the information here if you want to know, if you want to learn how to use it. It's relatively quick and there's lots of examples. So this is a typical example of finding a new package and using it quickly if you want to do something. So it would take a while to write the code to do this yourself, and before you have something complicated to do, it's always the best thing is to look or ask ChatGPT or Claude, has somebody else done that? Is there an open source package available? And if so, then just use that API and you can very quickly get productive. And that's what we're doing with Venn diagrams. So the way it works is we use matplotlib venn and we import venn2, and we have to supply sets. So we now generate our ATR significant results and our SLU7 significance results and turn them into sets. And then, so we have ATR genes and SLU7 genes, and then we generate a matplotlib figure as usual. But now we use this venn2 method here, and we supply the ATR genes and the SLU7 genes and the labels, and put this on the axis. And then there's different ways to configure this also. And in the notebook, we've made this a little bit nicer, and we supplied some more information. So we have some text here. So have a look through the code to find out exactly how this works. But this should be relatively straightforward.